Greetings, math fans. All right, so this is a graphing calculator worksheet for really to kind of get you ready a little bit for the AP exam, just to give you a little insight into how to use your graphing calculator. What we're going to be doing is we're going to be solving equations, going to be solving systems of equations, etc., and just kind of utilizing our graphing calculator capabilities. All right. So I have a virtual TI on this video, and we're going to kind of be switching back and forth to this, so hopefully it'll go somewhat smoothly. All right. So the first one, it says, using your graphing calculator to do the following problems. For number 1, it says, for which dimensions given below will the viewing window show a complete graph for that equation? So let's switch over to our TI, and you have your piece of paper in front of you, so I'm not going to have that out there all the time. And let's just type it in. So y equals negative 3x squared plus 12x plus 5. And you have to be kind of good with like the zoom keys. Okay, so for example, if I hit zoom standard, actually is kind of a nice zoom. It pretty much gets everything in. If you have like an error because it says out of range, zoom standard actually brings it in, puts the window in the correct place. It's not necessarily going to give you a good graph, but here's what my graph looks like. All right, and if you couple things you can do, you can zoom out. And sometimes that's you can't really see as much here, but let's actually look at the window now, because you can manually set the window. So you have all these different zoom things. You have zoom in, you have zoom out, zoom square. Zoom square actually gives you a very accurate graph, what things look like. That's kind of nice. Zoom trig is if you're using trig functions. You have that. We have zoom fit. That's kind of nice. Okay, so try, it's just good to try these. Anyway, let's set our own window here, though. Let's do zoom 6 again, zoom standard. And let's look at what the window was set at. Well, it goes between negative 10 and 10 for the x, and for the y is also negative 10 and 10. And that's actually B. So let's look at that graph again. Right? Yeah, it kind of gives us an okay graph, right? It kind of cuts off the top part of the graph, so it doesn't really show us everything. If I want to find like the maximum value, this is not a good graph for that. So let's go to another window, and let's do A, which is between 0 and 5 for x. So between 0 and 5 for x. And then y is going to be between 0 and 5. And notice I have a little, just so you can see what's going on, I don't even have to enter. This is just with the virtual TI. If you see right here, this guy right here, I'm kind of taking the arrow there. That kind of shows you what the graph is going to look like. So let's put a 5 here. So that's what my graph looks like, right? That's actually really bad because that's like way out. You barely see anything. If I actually do, if I graph that, this is what you see. Okay, terrible graph, terrible graph. Let us go then to C, and let's go to window, and we're going to do negative 5 to 10, negative 5 to 10, and negative 10 to 20. And we do graph. Ah, look at that. Beautiful graph, okay? So again, that kind of helps us, especially when in calculus, we're going to be looking for maximum values and minimum values. This is a great window now to have here to show you, to find that maximum value, and also to find the zeros, okay, where it crosses that x-axis. So C is definitely the answer for this one. All right? Let's look at the next one here. Use a graph to approximate solutions for the following equations. Round all answers to the nearest thousandth. So the deal is, math fans, you have this equation, you set it equal to 0, and I want to say, well, where is it equal to 0? I think the best way to go about doing this is to, instead of saying equal to 0, what if I set that equal to y? So y equals that function, and then basically what I'm trying to see is where does y, so where does y equal 0? Well, isn't that what a 0 is? Isn't that the where y equals 0? That's an x-intercept, or we call that a root, or we call that a 0. Okay, but that's how you solve these problems. Is basically you just graph this. Okay, so let's plug that equation into the virtual TI here. So let's clear this out of here. Do y equals, clear that out of there. And we're going to do x cubed minus 5x squared plus 6x minus 1. Okay, and we graph it. Oh, that actually gave us a nice window. Okay, so even if I do, let's do zoom standard, zoom 6. Okay, so it pretty much gave us a really nice graph. So if I look at this, math fans, I've got a couple places. Let me take my arrow here. Right, it's crossing at one place, two places, three places. There are three solutions, which kind of doesn't that make sense? Because it's x cubed, so there's possibly three solutions. Some could be imaginary, and so we don't know that. But by looking at the graph, I know that I have three real solutions. Okay, so this is what we're going to do. Is we're going to use a nice little friendly calculator, and we're going to hit second, calculate. And again, you can see all of my. In fact, let me clear this out here and start all over. Okay, so I'm going to do second, calculate, and again, it shows all my steps here on the right. Which is, so second, calculate, and I want to go to intersect. Or, I shouldn't say intersect, I should go to 0. Right, so I'm going to choose 2, or you can cursor down, and hit enter. Now it does, it says right bound and left bound. So what you want to do is you want to make sure that where it's crossing is the right bound is on the right side of where it crosses, and the left bound is on the left side where it crosses. Okay, so actually the right bound, I'm going to move this over a little bit. That's my right bound. Oh, it already did that. I guess I already did left bound. So you do left bound, and then you move to the right side, hit right bound, hit enter. And if you made a mistake, it's going to tell you there's no 0 there. Okay, so here's one of our answers. 0.198. So let's write that in there. Okay, so 0.198. That's an answer. Let's go back to the TI and let's do again second, calculate, and we're going to do 0, 2. And see, it starts with left bound. I just didn't see that before. And so let's go to the left side here. And it could be anywhere as long as on the left side of that, hit enter. And we'll keep going a little bit more to the right side of that. Hit enter and then guess. And so it's 1.555. So let's put that on here. 1.555. And the other answer is going to be right over here where it's crossing. So again, we have second calculate 2 for 0. And let's make sure we're on the other side of it. So here's the left bound. And we go to the right side and we do the right bound, hit enter again, and it's 3.247. 3.247. Okay? That's it. So that's pretty easy. Now I just want to show you what happens if you are not, let's say we do the same thing. So second, calculate 2. Now let's say our left bound is past this. Let's say we do this, and we hit enter. And we do our right bound, and we go here. Well, it doesn't cross at any place, so watch what's going to happen. Guess. No sign change. Quit. Okay? So that gives you an error, which is good. Okay? So that's pretty easy. So those are our three answers. Okay, so like our next problem is x minus 3 plus natural log of x. So let's do that one. Clear this out of here. X minus 3 plus natural log of x. Okay, and I like to close my parentheses, make sure everything's nice and clean. Enter, and we're going to do zoom. You can even see what the graph is going to look like here. Okay, so zoom 6. And it looks like it's crossing it. Now, let's say I'm looking at going, is this only crossing in one place? Well, we can always zoom out a little bit. Hit enter. And you can see it is. It's like going way, way, way out, right? All right. So let's go back to zoom 6. And I see it's crossing in this one location. So let's calculate out. So second, calculate intersection or 0. And left bound is going to be anywhere on the left side. Right bound here. Enter, and there we go. And you can see the y says 0 because of course it's y equals 0. It's giving us our x-intercept, and it's 2.208. 2.208. So let's write this in there. 2.208. Okay, that's pretty easy. Okay, so again, once you get the hang of it, it's really kind of nice. Okay, so let's do the next one here. You can do y equals, and we go under math, and we go to number, absolute value of x, plus math, number, enter, absolute value of x minus 3. And then, of course, it's minus 6 because we're solving for x, or we're solving to get it equal to 0, right? So subtracting x. And then we do zoom standard. And again, if you want to see what it looks like farther out, you can just zoom out. But let's do our calculate our zeros. So we're going to go left bound. Make sure you're left of the 0. Hit enter. And then right bound. And then guess. Okay, so there's one of our zeros. Negative 1.5. Okay, so negative 1.5. And let's find our other 0 here. Second, calculate 0. And we're going to go to this side. We'll get a little bit closer to our crosses. Okay, enter. And then go to the other side, the right bound. Enter, and then guess. And 4.5. Sweet. So it's 4.5. So guys, this is really pretty sweet because what we just did is we just used our graphing calculator to solve some of these complex problems. Okay, and you might look at 2A and say, well, I could use polysimult. Well, that's great to use polysimult for a cubic, but B and C, you can't use polysimult because it's not just an exponent of 1, right? It is it's got natural log or absolute value, so definitely using your graphing calculator kind of helps things out. All right, let's look at number 3. 3, find the solution to the following system of equations. Now, in this case here, I would probably use polysimult. Okay, I'm going to show you guys for the next few after that. There's a better way to do it. So let's, everyone should have polysimult in their calculator. In fact, there's a polysimult 2 on your calculator. But I don't have it on the virtual TI. So really what you want to do is you want to go under apps. Okay, so you go under apps, and you can even use your alpha key. So alpha P for polysimult. Okay, and there it is, polysimult. Hit enter. And we have our main menu, and polyroot finder, and we have a simultaneous equation solver, and that's what we're going to do. We're going to use simultaneous equation solver. Okay, so we're going to hit 2. Number of equations, there are 2 equations. Number of unknowns, 2. And the matrix now, the way we're going to put for this problem is going to be 3. Every time you hit enter, it moves to the right, which is kind of nice. So 3, -8, -14, and then -2. I'm putting the coefficients of the x, and then the y, and then of what is equal to the constant. 6 and 9.25. Enter. Okay, and then you hit solve, and it does its stuff. There we go, man. Of course, x1, x2 represent y, x and y, so the answer for this problem is -5, -1.2, -0.125. So let me write that in here in the notes. That is -5, -0.125. Sweet. Okay, now this one's a little more complicated, right? The reason it's a little more complicated is because it is not set up nicely, and it's quadratic or cubic, and you can't just you can't just solve for everything here. You actually have to do. There are a couple ways to do this problem. Okay, so let's talk about actually both ways that that we're going to do this. All right, so what we're going to do is put these 2 equations in our calculator, and we're actually going to use the intersect button. Okay, it's a really kind of a fancy little feature on our graphing calculator. The first thing I want to do is I got to solve for y for each of these. Okay, now so 2 ways you could do this problem. One is I could solve for y for each of these problems. All right, and then set those 2 equations equal to each other, and then move everything over to one side and graph that equation. Okay, and find the zeros. That's one way to do it. And then the other way to do it, which I think is just a lot easier, especially if you're given 2 equations, is to solve each equation for y and graph both of them and use the intersect button. Okay, and that's exactly what I'm going to do. So this equation, the only thing I need to do is add 11.75 to both sides. So it's a nice linear equation. And so let's put this into our TI here. Let's quit out of this. Quit out of here. And we got y equals 1/8 x. So you can write, parentheses are nice. You don't necessarily need these here because order of operation would be okay. But I'm just going to do it. 1/8 x plus 11.75. Okay, that's the first equation. And the next one is -x cubed plus 9x squared minus 5. Okay, and we're going to do zoom. Again, let's try a different zoom. Zoom standard. Okay, so that actually doesn't really work too well, does it? Okay, it doesn't work too well because I really don't even see what is crossing what. So let's try a couple other ones here. What about zoom fit? Okay, yeah, that one's not that great either because I really can't see everything. And sometimes what zoom fit does, it tries to get a lot of the graph in. If some graph is kind of funky looking farther out, it's going to make it really huge and it's not going to fit things in. So I'm going to go back to actually zoom standard. And what I'm going to do is I'm going to do my own window here. I'm going to say, well, let's go out to, here, wait, if I go graph again, I really trying to see what's going on here a little bit, obviously higher up for the y value. So let's try that. X min that's fine. We're going to leave it at that. X max, that's what I need to change. So I'm going to change that to 20. Oops, 20. Okay, and the y min is okay, but let's do the y max at like 30. And now let's graph it. Actually, you can even look on what's going on here on my little graph. You can see where I'm going to find out my solutions. Look at that. There it is right here, math fans. See, it's crossing it right here. Well, here I can graph it here too. But you can see it's crossing it 1, 2, 3 places. So I have 3 solutions. Okay, we're going to graph it. and then we're going to do second, calculate, and we're going to do intersect 5. Okay, now notice it's flashing over in that one spot there. Well, we need to actually get that, and it's actually on the graph of y equals 1/8 x plus 11.75. So how does it knows which graph we're on, or which line we're on, but it doesn't know which point I'm talking about. So I'm on, I need to kind of cursor over to get it close to the first point. Okay, so that's close to the first point. Hit enter. Second curve. Okay, it's on that line there, so we'll hit enter. And then guess. So that's our intersection. Okay, the intersection of that is negative 1.2. So it says round to the nearest tenth. So negative 1.3 comma 11.6. So let's put that on our answer key here. This is going to be negative 1.3 comma 11.6. That's our first solution. Well, we got two other solutions, so let's keep going here. And this one's a little touchy on mine, but your graphic calculator should not be as touchy at all when you're selecting. So I don't know, it's just some issue sometimes with the virtual TI. So let's do this again. Second, calculate, intersect 5, and let's get a little bit closer to. I don't want to be right on the dot because I think that's what kind of messes my thing up. You might be able to. So here, that one, hit enter. Second curve. My guess it's on the second curve someplace. Okay, so hit enter and then guess. And there's our next guess. So that one gave us 1.5 and 11.9. So let's write that down. 1.5 and 11.9. Okay, and then our third solution is going to be second, calculate 5, intersect. And again, let's move it closer over to that line and hit enter. And it looks like with mine, I'm just going to hit enter again because I know it's on the curve and I know it's going to be close to it. So I'm going to hit enter again and then guess. And there we go, 8.7, 8.8 and 12.8. Okay, so let's write that out. Solution 8.8 and 12.8. There we go. Those are our 3 solutions to that system of equation. Okay, let's do the next one here. Get y equals, clear these out. Okay, we're going to do 0.5x plus 2 and x cubed minus x plus 1. Okay, we're going to do zoom standard. And that gives us a pretty good indication. That's kind of a nice graph because we know one's linear and one's a cubic, so it's got that little bump there and comes back up again. All right, so you might actually look at this and go, I don't know, is that intersecting that one point there? So you know what I can do is, why don't I zoom in a little bit? Zoom 2. Enter. Ah, it's not. Very interesting. Okay, so it's only intersecting on top. So in fact, I'm going to set my window because I want to see it's going up a little bit higher. So I'm going to change this x or this y max to I don't know. Let's make it 5, and then graph. Okay, so now it's just a little bit closer, a little easier for me to see. I see one point of intersection here, and let's go second, calculate, intersect. Okay, there's our first, and it's right. This one doesn't matter because there's only one point of intersection. So that's our first graph, that's our second graph, and then guess. There we go. So it's 1.48 and 2.74. 1.48 and 2.74. Okay, that's not bad. Let's do the. Alright, math fans, 3D is actually the most challenging problem of all. The only reason it's the most challenging is because it has really the most extreme values. If I look at y equals, let's actually kind of look at some of the stuff here. If I look at y equals 115x minus 3x squared, that's really pretty extreme too, okay? Because we've got definitely a parabola, it's opening down, but one of the things it's got a vertex, and remember, if you find the vertex, it's opposite of b over 2a, so it's going to be negative 115 over 2 times negative 3, which is equal to 19.17 approximately. If I plug that back in the equation, its vertex is 19.17 comma 1102 approximately. Okay, that's a pretty extreme number, that 1102. And even that y equals cosine, 50 cosine of x, that has an amplitude of 50. Okay, so, it's kind of extreme. What I'm going to probably do is, if I'm looking for the intersection, I'm probably looking for something that is going to be in a y value of 50. So what I'm going to do for this problem is I'm going to kind of estimate my y value a little bit, and I'm going to say my y value, I'm going to make that maximum of 100 and minimum of negative 50. Okay, and then I'm going to make my x value, and it's kind of, you're doing 115, let me write this out here a little bit, 115x minus 3x squared. We're kind of saying, hey, what does it even cross that x-axis? Okay, and so I'm going to say, well, it's I can factor out a, let's write it in this form here, negative 3x squared plus 115x equals 0. So I can factor out a negative 3x, and I get x 115 divided by 3 gives me about 30. Again, we're just doing rough numbers, 38 and a third. So minus 38 and a third equals 0. So I know it's crossing at x equals 0, and it's crossing it at 38 and a third. Okay, so just kind of getting a little bit of an idea of where things are going to be here. It's probably going to cross. It's going to cross that cosine graph somewhere in there too. Okay, and we'll see as we actually make a quick sketch here. But I'm going to make my window then the y value between negative 50 and 100. And I'm going to make my x value between, we're just going to do like negative 10, and we'll do about, I don't know, about 60. We'll just kind of give it a little leeway on either side. All right, and so let's put these in the graph. Let me move this over here so I have my numbers. I see my numbers here. So let's put the equation in. Y is equal to 115 x minus 3x squared, okay, and 50 cosine of x. Alright, we are in radian mode, I believe. Just check it. Yep, we're in radian mode. Okay, that's very nice. Oops. Okay, so let's, if I just want to show you, if I do zoom standard, zoom 6, okay, that is really ugly. It doesn't give us a very good graph. This is the cosine graph going up and down here, and as we already figured out, our vertex is huge. It's 19.17 comma 1102. That's a huge vertex. I don't even see it in here, okay? Because if I check out my window, look at that. Look at what it gave me as a window. Negative 10. I mean, it's not even close to what I need. I need for an amplitude of 50. So let's actually put those values I figured in here. X min is, we're going to do negative 10, and X max we're going to do 60. Okay, Y min negative 50, and Y max 100. Okay, and then we're going to graph. Okay, and this is actually not even that great too, because part of the deal, math fans, is you guys know it's crossing at 0, 0. See this big old thick black line on the left here? somehow that's crossing over there. Okay, and what's going on is that's actually kind of getting interfered with by that axis just to even view it. So here's another thought for you, just to kind of help me see it. I'm going to go to my second zoom, which is format, and I'm going to turn the axes off. Okay, so I'm going to turn them off, and then I'm going to graph it. And you can see that's it's crossing in these two spots right here. Okay, so that's where the graph is crossing. And in fact, if I kind of zoom out a little bit, well, I don't have to zoom out, but I can see it's going to cross in two spots. All right, and all right, so now once I have that, just to kind of get an idea where it's at, because part of the deal is sometimes just zooming in just to see where things are. So let's actually do our calculation here. Second calculate, intersect, and first curve. Sometimes it's even hard to see where that first curve is. So here we go. I kind of did a cursor over here. You can tell my first curve is actually on that the parabola. And one of the reasons why I could tell that is because look at the y value. The y value is 130. And what's the maximum value on that cosine graph? It's going to be 50, right? It's the maximum value for that because the amplitude is 50. So, but we want to get kind of close to that. So here we go. We're right. If you see that dot right now, we're there. Okay, and then second curve, I'm just going to hit enter because it's flashing right by that spot too. Guess, and there it is. So my answer, I got 0.40 and 45.97. So let's actually write that down here. I'm going to put this over in this spot right here is my solution. Okay, and that's going to be 0.40 and 45.97. That's one of my solutions. Okay, again, it's a little tricky, but we're going to deal with it. Okay, so let's find our next solution here. So second, calculate intersection, and let's see. Look at how big that y number is getting. Right, I'm going to the other side of the parabola. You can tell. And what am I going to do? I'm going to go up to the vertex is 1102, so it's going to go all the way up to 1102, and then it's going to start coming down again. So here we are, we're at 1099. There's actually here we are, right? This is 1102. There's our maximum value, and now we're going to start coming down again. So again, we're going to get kind of close to this. You're going to see it's going to show up. There it is. Okay, see there's the dot. So let's hit enter. We're kind of close to that. And then our second curve is going to be right at that spot too. Hit enter and guess, and there's our other answer. So it's 37.90 and 48.97. So that's our other answer. So 37.90 and 48.97. Okay, so that was tough because we had to do a lot of stuff to kind of see where things were in the graph. I turned off my axes so I could see this left-hand line over here. Had to zoom in correctly. So sometimes kind of having an idea of what the graph looks like helps a little bit to actually get your window correct. All right. So again, probably the toughest one, just because your calculator is not that smart. It can't just get the window the way it needs to. All right. Let's look at our next problem here. Okay, number 4 says find all real zeros. This is really the same as before, except we're plugging in the equation and we're finding the zeros with our with the calculator. All right, so let's go here. I'm gonna actually, just because I want to put back my axes here. Let's turn our axes back on. Okay, so quit out of here, and y equals. Let's clear that and clear that, and let's stick these in here. So we have negative 6x cubed plus 25x squared minus 23x plus 6. Okay, that's our first equation. Actually, that's our only equation, right? Okay, and then let's we can do zoom standard, And there's the graph. Now, this is interesting. Look at that. It looks like it could be hitting it right there. I'm not 100% sure. So what we can do is we can actually zoom in a little bit. Okay, so let's zoom in. Ah, look at that. Very interesting. It is actually crossing that graph. Okay. So let's do zoom standard. So it's really crossing it in 3 places. I want to go back to zoom in here, right? It's crossing. Let's actually zoom in a little bit more. And there it is. Okay, it's crossing it in 2 places. So let's do it just for the heck of it. Let's do our window, and let's say that's our x min, and I can change our x max to, I don't know, 3, just to kind of see where things are. Okay, so you can see it hits it in 2 places. And so let's do a couple calculations here. Let's find a 0. Okay, left bound. Okay, so there it is. Okay, there we go, left bound. So I want to find that first one. Enter. There, okay, and then right bound, enter. And so there it is. Oh, negative, or it's 0.5 comma 0. So it's pretty sweet. So let's write that in here. 0.5 comma 0. Okay, and of course you can just write, the zeros are really just x equals, we're looking for really x equals, right? X equals 0.5, so I'll just write that down. Okay, let's go back to our calculator here. Second, calculate 0. And then let's go for our next one, so our left bound. Let's go to the left side of that, and then to the right side of that. Enter and guess, and it's 0.6666, which is really 2/3, right? But we can write it as a decimal, it's fine. It's 0.67. It's another one. And we actually had one more, if you guys remember seeing that one. We have to just zoom in differently here. In fact, let's zoom again. Zoom 6. And let's find this other one here. This one that looks like it's around 3, but it might even be 3. So second, calculate 2. And let's just okay. So let's do this guy here. That's the left bound and the right bound, and enter and 3. Now look at this, math fans. It says x equals 3 and y equals negative 5 e to the negative 12. Okay, what you need to understand is that y negative 5 e to the negative 12 is really 0. Okay, because it's negative 5 times 10 to the negative 12, which is negative 0.000 and a whole bunch of zeros and a 5. Alright, so that truly is 0. It's just the calculator rounding. So that's our other answer, is 3. Okay, it's not too bad. Okay, let's try the next one here. We have x squared minus 3x plus 4. Okay, we're going to zoom standard. Very interesting. Well, we know this is a parabola, okay, and look what's happening. It's not crossing at all. In fact, just for the heck of it, this is what it shows. If I do calculate my zeros, and I do left bound, and I do right bound, so I go to the other side of the vertex, hit enter, and guess, it says no sign change. All right, which pretty much means I don't have a 0 between those 2 values that I gave. All right, so this guy is find all zeros, so it's none. All right, let's try the next one. Okay, so I get y equals x times the square root of 9 minus 4x squared. Close your parentheses. Okay. And this is also give the domain and the range for this problem too. So remember, domain is your x values, range your y values. Alright, so let's do zoom 6. Ah, very interesting. Okay. Let's zoom in on that one a little bit more. Very interesting. It looks like it's actually kind of stopping a little bit here. Do you guys see that? And why would you think it's stopping? Why is it not? Why does that graph not continue? Okay. Well, the main reason is because that 9 minus 4x squared, that number has to be what? It has to be greater than or equal to 0. Okay. So that is that's what's going on here. Let's actually, first of all, let's find our root, because that's what they asked you. They asked you to find the zeros. So second, calculate 0, and let's do left bound. We'll go to the left side and then right bound that side and hit enter. So it does. It crosses the it crosses at the origin. So that is our root, 0, 0, or x equals 0. Okay. So this is what the deal is. We have the domain. Let's go back at our calculator and just take a look at it. Our domain is x values. So I'm saying, what can the x values be between? Well, what you're going to do is you're going to say 9 minus 4x squared, right? Doesn't that have to be greater than or equal to 0? All right. So what I'm going to do is I'm going to find my critical points, and I'm sure you guys learned back in Algebra 2 in 328 how to find this, and I'm just going to do a little interval testing here. So I'm going to find critical points, which are basically, I'm going to say 4x squared equals 9. Okay, I'm going to move like the 4x squared over, and I get x squared equals 9 over 4. So x equals plus or minus 3/2. Alright, and then what I'm going to do is, if I do my interval testing, I get negative 3/2, and I get 3/2. And I'm going to test to see where it's true. And so if I put a 0 back into the original problem, 9 minus 4 times 0 squared is 9. Is that greater than 0? Yes. So really, this area right here is where it's true. If I do something, let's say, greater than that, that's going to be false, right? If I do, for example, 2 squared is 4, 4 times 4 is 16, 9 minus 16 is not greater than 0. So what I can say for this right here that I just did, the domain, is going to be between negative 3/2 and positive 3/2. Okay, and then my range is basically the y values. Okay, what is the maximum value for the y values? Now here I'm going to show you another little fancy schmancy feature on your TI. I just figured out my x values for that, right? Just based on interval testing. But if I want to actually find out my y values, maximum or minimum range values, I can use a function called, let's go to it and we do second, calculate, and I'm going to do we're going to do minimum first. So I'm going to do minimum here, 3. And again, it's going to ask me for my left bound, so I'm going to go to the left here of that. It's like a little vertex here. Hit enter, and go to the right side of that. Hit enter, and guess, hit enter again. So the minimum y value is negative 2.25. So let's talk about, this is our, move this over a little bit more, our range is between negative 2.25, okay, which I actually could have plugged in my domain, right? No, not really, because if I plug in my domain, that doesn't necessarily give me the values for my range. In fact, if you look at the x value, it's negative 1.0, right? It's some other random number. I'm not even at my minimum domain. In fact, if I cursor over here, look what happens. Oh, it's not. I guess it's not on the graph now. if I do second trace, or just if I do trace, right, cursor over. Remember I told you my domain is -3/2, so the smallest number is going to be -1.5. And notice how it still gives me -1.54, but it's off the graph. The y value is not, it's not giving me a y value. Okay, so here's a y value, -0.53, and it's -1.48 for the x value. Okay, so let's keep going here. Second calculate, let's do a maximum value to find out our maximum y value, which is the maximum value gives us our maximum range. So we're going to do left bound of this little vertex right here. Enter. And the other side, guess, and positive 2.25. Okay, so let's go back onto here, and it's 2.25. There we go. So that's my range. All right, and that's using the graphing calculator. The domain is actually easier to figure out because you can say, what can the x values be? Well, I kind of know that square root can't be negative, so that's why I set that 9 minus 4x squared to greater than or equal to 0. And then the y values sometimes are a little bit more challenging. Okay, but here we used our graphing calculator to figure that out. That was kind of nice. All right, let's, we got a couple more to do here. So let's do letter D. Okay, so we're going to say x squared minus the square root of 0.5x minus 3. So it's all under the square root, so it's in parentheses there. Oh, sorry, it's not under the square root. I'm looking at e. So I'm going to go move that over. That close parenthesis there, minus 3. That's going to give us a correct graph. Okay, so let's do, we're doing D first. All right, and hit enter, and then I'm going to do zoom 6. Very interesting. Okay, that's what our graph looks like. And let's find our zeros. Second calculate, that's actually pretty easy now. It's going to be left bound, enter is right there is fine, and right bound is great, and then enter, so it's 2. So there we go. That's our answer for that one. Only crosses in one place. Sweet. And you know, you might sometimes, you kind of have an idea of what the graph is going to look like. Okay, it's typically would be a parabola, right, with the x squared. But of course, you have somewhat of a restriction with that 0.5x because that can't be negative. So it restricts you from putting a negative value in there. All right, so that's why we only have that one root. All right, so let's look at E. And we're going to do x squared minus the square root of 0.5x minus 3. Now that's all under parentheses. And so we're going to do zoom 6. And you're like, oh man, I don't really see anything here. So maybe I need to zoom out a little bit. Okay, and I don't even see any graph there, right? But you know what I want to do is I want to take off the axes again, because what's going on sometimes, as I told you already, is that axes gets in the way. So let's turn that off. And graph. Okay, well I don't even see anything yet. So zoom out again. There's the graph. Okay, let's even zoom out a little bit more. So it looks like, and you see how it says x equals 0, y equals 0 on here? So it's basically not even, it's going almost straight up. It's a really, really big graph, okay, and it's not even crossing that x-axis at all. So the answer to this guy here is none. Okay? Alright, so again, you know, some kind of challenging little problems here just to see what things look like. Okay. Okay, number 5, sketch a complete graph of y equals x to the 2/3 power. Okay, we're going to be using this in calculus quite a bit, this type of problem. Let's put it on our graphing calculator. Even before I do that, let's think about what that's going to look like. Would you guys agree that that x to the 1/3 power, that kind of doesn't get very big, right? It actually decreases. You're taking the cube root of something, but the squared makes it a little bit bigger too, and the squared actually makes it positive, give you positive values all the time. So actually I need to turn on the axes again, because I like my axes on. Okay, and then let's type in this guy right here. It's x raised to the parentheses 2/3 power. Okay, and then we're going to do zoom 6. Interesting. Okay, so that graph looks like this. Okay, it'll never go negative because you got the squared part in there, but it actually doesn't grow very big at all because it's less than x, just at y equals x. It's to the 2/3 power. So that cube root actually kind of makes almost like an exponential decay. Okay, so it's like if you graph the square root of x, the square root of x actually looks like this. Okay, so that's kind of what that looks like, except it's on both sides, because you have that squared makes everything positive, so you never have to worry about taking it's also the cube root. So you don't have to worry about anything being negative because you can take the cube root of a negative number, and that's fine. Okay, so let's just kind of give us a little idea what that looks like. Okay, so for problem number 6, for the given function, find the relative max and min points. Sketch the graph, give its dimensions of your viewing area that shows these points. Round your answer to the nearest thousandth, if not exact. All right, so kind of a key word here, math fans, is this word right here, relative. Okay, so obviously we're going to find relative maximums and minimum, and by the way, they are points, so we need to give an XY answer. Okay, so what I mean by that is, let me just make a quick sketch here. If I do something like this, all right, a relative maximum point means that on both sides of, or on one side and then the other side of that maximum, it's lower than it. So this value right here, that's a relative max because it's a high point. Okay, this is another relative max. That's a high point. There are lower points below it. Okay, this arrow is, and you can't look at the arrow, these arrows right here, because they go to infinity. So I don't really know what's going on after that, but whenever you see like a little bump or a dip, like those, like I said, these 2 points are maximum points, and this point right here and this point right here, those are relative minimum points because there are high points around it. Okay, and you can't, so this one that goes down, that's not a minimum point because it goes down to infinity. You can't look on the other side and say, oh, it's starting to go up, because it's not. It continues down. Same thing with this one. It just keeps going up, so that's not a relative max because it just keeps going up. Okay, so that's, again, relative max and relative min are high points or low points of a graph. So let's take a look at the graph that we have here, and let's type this one in. So y equals x cubed minus 2x squared plus x minus 30. Okay, and we're going to hit zoom 6. And this is kind of what the graph looks like. Now, this is a little bit older application here, so it's kind of a rough looking sketch, but basically I look at it, it looks like a vertical line. You know, I mean, obviously it's tilted a little bit, so something's happening someplace on that graph because it is an x cubed. And you guys should kind of recognize if it's an x cubed, it's probably going to look something like this. Someplace it's going to look like that. That's my guess. Okay, that's what an x cubed looks like. So as opposed to a x squared as a parabola, this is you know, basically a high point and a low point. So it probably does have a relative maximum and minimum. Basically, we'll have a difficult time on your graphing calculator to figure this out. Okay, I'm just going to kind of tell you where the maximum minimum is. You're going to be able to do this much easier when you take calculus. Okay, but I just want to kind of show on your graphing calculator. So what we're going to do is we're going to set the window my y value, I'm going to set it to negative. Minimum value is negative 31. And the maximum value is going to be negative 29. That's actually where the little bump occurs. Really small. If you didn't know that, it would be really tough to find that. So now don't hit zoom or anything, just hit graph. And it's going to zoom in that one little spot there, and you can see what's going on here, right there. See that? It's like I said, this is a little rough sketch here, but there's a bump there. It goes up a little bit, then back down, and then back up again. So that is where you're going to find your relative max and min. Again, when we get to calculus, it'll be easy to find this. Here it's a little difficult, but I just wanted to show you on your graphing calculator. So now what I'm going to do second calculate, and we're going to find, let's find the maximum point first. So we're going to do 4. And then it's kind of nice, it's right on the left of it. So we're going to hit enter for our left point. And then we're going to cursor over a little bit. Okay, and make sure it's on the other side of it. Hit enter, and then guess. Okay, so that is your maximum point, negative 0.333, rounded to the nearest thousandth, comma, negative 29.852. So let's just write that in there. It's going to be 0.333, comma, negative 29.852. Okay, so again, I'm asking you for points. Make sure you give it to me, okay? As opposed to if I asked you a maximum value, that would have been just a y value. You would have said negative 29.852. All right, so let's go back to our calculator here. And now we're going to find a minimum. So we're going to do the same thing. We're going to do second, calculate, and then minimum, so 3. And we're good over there, so we're going to hit enter. And then go to the right bound, so any place to the right of that bump. Okay, it looks good. Hit enter, guess, enter, and we get 1.000, so it really looks like it's 1 comma negative 30. So 1 comma negative 30. Okay, and so those are your relative max and min. Again, difficult to find on here, but that's basically how you do it. You look for the bump, and you can check, you look at right bound, left bound, and then you do your guess, and you get it with your graphing calculator. Okay? All right, so our last problem here, number 7, says find the maximum and minimum values of the following functions over the given interval. Now they give you an interval, so we're going to graph this. It's negative x squared plus 3. And by the way, when they talk about maximum, right, maximum and minimum, this is when I don't say relative, that means I want to know the absolute. We're going to use the word absolute. A-B-S-O-L-U-T. Absolute, which we'll see a lot in calculus. So it's an absolute maximum. That means the highest point between those two values, and the minimum value, these are y values, of course, and then the minimum values, which is the lowest point between those values. Okay? Not relative, but actual minimum and actual maximum point. So if I put it in my calculator here, so we're going to do negative x squared plus 3. And I'm going to set my window now because I have between negative 4 and 4. And then I hit graph. And I can see I made a mistake right away. So I'm just going to point this out because you're like, well, what the heck? Why is this not in? I don't even see it. Well, I didn't change my y value. So really a good thing to do right off the bat here is you do zoom 6. Get it into something you actually can see. And that's what the graph is. So now when I actually choose my value or my window, the y value is going to be, it's going to show me all the y values, which actually is really nice. So let's go back to, I said our window. Now we're going to do between negative 4 and 4. All right, and now if I do graph, it'll give me, there it is. That's the graph between negative 4 and positive 4. So I can look at this problem and I can say, oh, the maximum is this high point right here. Okay, so again, if I want to use my calculator, I can see second calculate maximum. So it's 4. And just make sure we're to the left of that. Hit enter. To the right of that. hit enter, guess. You probably could have guessed it's 3 because it's in, 3 is your high point when x is 0, y is going to be 3. That's basically your vertex, right? Opposite would be over 2a. So anyway, my maximum value is 3. Okay, the minimum value, let's go back to this. Basically, you can see that it's going to occur, since it's a parabola, it's going to occur at the end of the range. So I gave you guys the interval is -4 to 4. So it's going to occur at -4 and it's going to occur at 4. So if I hit second calculate, I can actually just do a value. I mean, you can't really do a minimum here, because if you actually hit minimum value, it's looking for a high, remember if you find a minimum, it's looking for 2 high points. Well, it doesn't have that because remember the graph is a parabola and it doesn't have, it just keeps going down, but we're actually ending it at -4 and we're ending it at 4. So that means the 4 and the -4, by the way, there is a bracket if you notice that, which means it includes that point. You're going to type in, so if I do that value and I type in -4, which you don't really need your calculator to do this, you get -13. And you guys know since it is symmetric, if I type in 4, I get also -13. Okay, so that's my minimum value between -4 and 4. They're both -13. So that's what you, -13. Okay. All right. So let's do the last one here. Move the calculator over. It's 2x cubed minus 15x squared plus 20. So let's type that guy in. X cubed minus 15x squared plus 20. Okay, and then we'll get nice thing, zoom 6 here to get us into something pretty good here. And, so it's a nice cubic, right? You can see it goes up and then back down again, then back up again. So, and again, we're going between 1 and 5. So let's set our window between 1 and 5. And then we hit graph. So what's going on here is you can see right here in this one spot at 1, right, it's going down from there. So I'm just going to zoom out again. So do you guys agree that at 1, so if you look at the tick marks on here, 1, 2, 3, 4, 5. I'm not sure about the 5, but just because I have the kind of the 1 in sight here, do you guys agree the 1 is really going to be the maximum point? Everybody agree with that? I hope. And again, this is just by observation. When we get to calculus, you're going to see it's a lot easier. But if I plug a 1 in there, that is going to, so we're going to do second calculate value, and we'll put a 1 in there. And that gives us 7. Okay, so 7 is our maximum value. So I'm going to write that in. 7. And now let's see what's going on at 5, because maybe this is what could be going on. Okay, when you get to 5, we don't know if this is, let's say this is 5 here. Maybe there's something going on here, right? But obviously they're looking for a minimum value, so it'll be something over here. If 5 happens to be on this side, then actually 5 would be the lowest value. So you kind of need to zoom in a little bit to see what's going in at 5. So let's do that. So I'm going to change I'm going to go back to actually zoom 6. All right, and then I'm going to do my window. I'm going to do my x min is going to be instead of 1 to 5, I'm going to do like 3 to 6 just to see what's going on over there. Okay, And then I want to go a little bit lower for my y values. So I'm going to go from negative. I'm just going to go to, just because again I kind of know this. Y minimum is going to be negative 120. And y max is going to be negative, we'll say negative 50. And we hit graph. We can see what's going on. Okay, so that's actually the bottom of the curve. It's probably easier on your calculator because this is like kind of almost like an old-fashioned graphing calculator on the TI Smart View. But we have to investigate it a little bit. So just because I don't really know quite what that value is. So if I actually do, let's find out what that minimum point is. So second, calculate value. No, I want to do second. Second calculate minimum, which is 3. Hit enter. And cursor over a little bit. You can even look at the x value. Look what's going on with the x value. Okay, well, it's going to be interesting what's going on here. It's the bottom of the parabola, so let's see. We're on the other side now. Hit enter. Guess. And look at that. The x value is at a minimum. Okay, so that is actually the bottom of that part of that parabola there, and y value is negative 105. So I wasn't sure if that was like, let's say this came out to be negative. If it came out to be negative 6, then I'd have to look for negative. The negative 5 would actually be our low point. We have to go over here, right in this area here. Let's say this came out to be negative 4. Then negative 4 would have been our answer. So whatever that minimum value was, but because of if the low value would have been, it came out to be the exact value, basically that 5, right? The value of the endpoint. Okay, so we can say y value is negative 105. So don't get frustrated with, like, oh man, how, zooming with the calculator. You guys are definitely going to get better at the calculator. Just understand. Kind of like some of these words. If I say absolute, that means, hey, I'm looking for in an interval, what is the biggest value and what is the smallest value for absolute max and absolute min. If I'm looking for relative, I'm saying, hey, where's there a bump? Okay, that could be a minimum or it could be a maximum value, depending. All right, so I just wanted you guys to learn a little bit about your calculator, and hopefully you guys are kind of good to go with this worksheet. Okay, that's it, math fans. Have an outstanding day. Adios. Goodbye.